Hi, welcome to the chapter of Statistics 1. In Statistics 1, we will study about mean, mode, median, range, and then standard deviation. As usual, first we will discuss about the theoretical aspects of these mean, mode, median, range, and standard deviation, and then we will go on to solve some problems related to these concepts. So in statistics, what we have is that we have enormous amount of data. This enormous amount of data, however, that we have is unorganized, it's scattered, and thus it remains quite difficult to understand this data. How can we understand this scattered, unorganized, and incomprehensible data? In statistics, we use some special tools of statistics to understand this data. We organize this data, or we make a smaller representative data set of this larger unorganized data set in order to understand what this data is telling to us. Mean, mode, median, range, and standard deviation are these different tools of statistics that help us to understand this unorganized data, to organize the data into some smaller subset which then we can understand easily. So these tools of statistics simplify our understanding of this large amount of data. First tool to simplify this understanding of vast data is called mean. This mean you would have already read in your earlier classes. This mean is also called arithmetic mean or average or also arithmetic average. So suppose if you have a data set of these 5 values, that is 3, 2, 5, 1 and 1. Suppose this data set is say hamburgers that Clark ate on 5 consecutive days. Now someone wants us to tell that how Clark ate hamburgers on the 5 consecutive days. If you do not know the understanding of mean, then you will have to say that he ate 3, 2, 5, 1 and 1 number of hamburgers on the 5 consecutive days. You see that this data consists of 5 different data values. So it's something kind of more difficult to remember and to make a understanding of what this data is telling us. Instead, why don't we just find out what is the arithmetic average of this data set? So the formula of arithmetic average remains same as you have read in earlier classes, that arithmetic mean or simply mean equals to sum of all data values of the data set divided by total number of values in the data set. In this case, we have total 5 different data values, that is 3, 2, 5, 1 and 1. So our mean then shall be sum of all those data values of the data set, that is 3 plus 2 plus 5 plus 1 plus 1, and total number of data values in data set is 5. So then the average shall come out to be 12 divided by 5 or 2.4. So now if you say someone that Clark ate on an average 2.4 number of hamburgers daily on the 5 consecutive days, it is now a smaller amount of data you are telling. It's more easy to comprehend 2.4 number than this lengthy number set, that is 3, 2, 5, 1 and 1. So that's how you see we have simplified our understanding of this large amount of data. There is another concept, there is another special tool is called range. Now range tells us the spread of this data set, that is difference between the greatest data value and the lowest data value, that is the highest data value and the smallest data value. In this particular example, 5 is the highest data value and 1 is the lowest data value. So the range, that is spread, then shall be 5 minus 1 equals to 4. So you see that the range tells us spread, and this range is in fact another special tool of statistics that helps us to know how data is moving. Now, another important tool is called mode. Now mode tells us about which data value is occurring most often, that is for which data value the frequency is maximum. For this earlier example, 3, 2, 5, 1 and 1, you see that frequency of 3 is 1, frequency of 2 is 1, frequency of 5 is also 1. However, the frequency of 1 is 2 because 1 is coming 2 times. So you can see that this data value 1 is coming 2 times, its frequency is 2, it's coming most often, and hence the mode is 1. What if the data values would have been 3, 2, 5, 5, 1 and 1? What would have been then mode? We need to find out the frequencies of different data values again. For the 3 it's 1, for 2 it's again 1, however for 5 and 1 it is 2 and 2. So the mode then would have been both 1 and 5. Now we move on to median. Median is again another our tool of statistics to understand data. Now the median always tells us the middle value of the data set. So what median does is that it bifurcates all of the data in 2 data sets. In one of the data set is the lower half, while another data set is the greater half. And the median sits just between the 2 data sets, such as it bifurcates all of the data in the 2 data sets. How we do so? Let me explain you through one example. The data set again is the same 3, 2, 5, 1 and 1. However, when you want to know what is the middle value of this data set, we have to ensure that we arrange it. By arranging it means that we have to arrange it in either in ascending order or in descending order. I have arranged this data set in ascending order and I have this 1, 1, 2, 3, 5. Now I have arranged this data set. Now next I want to know the middle value of this data set. Now the middle value of this data set you see is 2. Because 2 is just exact in between this data set. There are exactly 2 number of data values which are lower than median, and then there are exactly 2 number of data values which are more than 2. 1 and 1 are lower than median value, however 3 and 5 are greater than our median, that is 1 and 1 is 1/2 and 3 and 5 is another half. 1 and 1 is the, I can say, is the lower half, while 3 and 5 is greater half. So what you see that the median here is bifurcating all of the data into 2 equal parts. However, these 2 equal parts must have equal number of data values. Now in this case, the number of data values in the data set was odd, and hence we could easily find out what was the middle value. What if the data set has even number of values? For example, consider this data set 3, 2, 5, 1, 1 and 1. Now I am arranging it in ascending order and I have the data set as 1, 1, 1, 2, 3 and 5. Now you can clearly see that there is no middle value in this data set. I do not have any middle value for which I can say that exactly some number are less than that and exactly this number are greater than that. So in this case I find out the 2 middle numbers, and then the average of data corresponding to these 2 middle numbers is going to be our median. You see that the total number of data values in data set is 6. So the 2 middle numbers are going to be your 3 and 4, and then the median shall be average of third data and fourth data. Third data is your third one and fourth data is 2. So then median is going to be average of 1 and 2 and it shall be 1.5. Now you see that 1.5 is kind of a number for which exactly 3 number of data values are lower than it and exactly 3 number of data values are greater than it. What we have done is, again, we have bifurcated this whole of the data set into 2 equal parts. One part is lower half and the one part is greater half. Now we can also deduce a general formula for median. If there are odd number of data values in a data set, then our median shall be n by 2th number and you round it up to the next number. In our earlier example, there were total 5 number of data values there, that is odd number. So our median then shall be n by 2th number and we round it up. n by 2th is 2.5. So 2.5 we round it up to the next number comes out 3. So the data corresponding to the third number then shall be our median value. However, we have already arranged it in ascending or descending order. If you have arranged in ascending order, you will see that the third number again is 2, and then the 2 is our median. Similarly, if the data values in the data set are even, then our median then shall be average of two middle values. These two middle values are n by 2th number and n by 2 plus 1th number. That is average of third and fourth number in case of our second example. In our second example, we had our 6 data values in the data set. So the average of n by 2 and n by 2 plus 1th number. N by 2 is 6 by 2, that is 3, and n by 2 plus 1 is 3 plus 1, that is 4. So the average of third data and fourth data. Third data was 1 and fourth data was 2, and hence our median then shall be average of third data and fourth data, and that was 1.5. Similarly, if I want to know, suppose in a data set there are 100 number of different values, and what shall then be the median of this data set? If there is 100 number of values, that is it is even, and then the median then shall be average of 100 by 2 and 100 by 2 plus 1 data sets average. That is average of 50th and 51st data then shall be our average. Again, we have already arranged this data in ascending or descending order. Let's solve some problems on mean, mode and median. So the first problem is average of a set of 3 numbers is 20. When another number is included in the set, the average increases by 10%. What is the value of the number that was included? We start with the first linguistic statement, and we will make a mathematical expression of that first linguistic statement. The first linguistic statement says that average of set of 3 numbers is 20. I do not know the 3 numbers, neither I do want to know. Let's say these 3 numbers are x, y and z. So I can write the mathematical expression as x plus y plus z divided by 3 equals to 20. And now I have is x plus y plus z equals to 60. I'll say that this is equation number 1. Now the second statement, linguistic statements, tells us second equation. Now the second equation is x plus y plus z, then another number that I don't know, I'm taking it as a plus a divided by 4 equals to 22. Average of the 4 numbers now is 10% more than 20. 10% more than 20 is 20 plus 10% of 20. 10% of 20 is 2. So 20 plus 2 is 22. So our second equation then comes out to be x plus y plus z plus a divided by 4 equals to 22, or we can solve it as x plus y plus z plus a equals to 88. Now from the first equation we can put the values of x and y and z, and 60 plus a equals to 88 and a equals to 28. So you see how we solve this problem. The next problem. In a class, 10 students scored an average of 70 grades, and the remaining 15 students scored an average of 80 grades in their midterm math exam. What is the average of the entire class for midterm exam? Okay, I'll just go on in the the way I did go in the first example. I'll convert the first linguistic statement into a mathematical equation, and then second linguistic statement I will convert it into second mathematical equation. I'm going to write something like this: sum of grade of 10 students divided by 10 equals to 70, or I have is sum of grades of 10 students equals to 700. Similarly, for the second linguistic statement, the mathematical equation then shall come out to be sum of grades of 15 students divided by 15 equals to 80, or sum of grades of 15 students equals to 1200. Now we have two equations. Now, however, the problem wants us to know what is the average of the entire class. The average of the entire class, then the formula shall be same, and that shall be sum of grades of all the students divided by total number of students. Total number of students in the class is 10 plus 15 equals to 25. The word remaining here is important because it is telling us that after 10 only 15 students are left, so the total number of students in the class is 25. And in the numerator, the sum of the grade of all 25 students means sum of grade of 10 students plus sum of grade of remaining 15 students. So I have in the numerator 700 plus 1200 and the denominator 25. So I have is 1900 by 25. So average comes out to be 76. When you go on to solve 1900 by 25 using your calculator, it will come out 76. Let's solve another problem. The another problem says that a group of 20 movie critics were asked to rate a movie on a scale from 0 to 5. The results are as follows. Now we have been given a table in which there is in the first column ratings have been given, and in the second column we have been given frequencies. Frequency is nothing but number of critics. Now this table in fact is also called frequency table. Now the problem may ask us what is the average, what is median, and what is mode. Similarly, I can also ask you what is range. Now you need to understand that what this frequency thing is telling us. The frequency thing telling us is that of those 20 different movie critics, only one gave the movie 1 star. 4 movie critics gave the movie 2 stars, 6 gave it 3 stars, and 7 gave it 4 stars, and only 2 gave it 5 stars. What in fact we have done is that we have arranged data in a more suitable way. In its more raw nature, the data would have been something like this, that the ratings given by movie critics of the movie are 1, 2, 2, 2, 2, 3, 3, 3, then 4, 4 and 5, 5 and like this. Now this would have been a cumbersome data, would have been a great amount of data, so it have been just written the same data in a frequency table. These frequencies are telling us that rating 1 is given by movie critic only once. Now the average, we first find out what is average. Now the formula of the average remains same, that is sum of data values of all the data set divided by total number of data values. Total number of data values here we have 20, because there were different 20 ratings were given. By some movie critics rating was given 1, by some 2, by some 3, by some 4 and by some 5. So total number of movie ratings given were 20. So the total number of data values is 20. So the average then shall come out to be sum of all data values, that is 1 plus 2 plus 2 plus 2, or I can more easily write it as 1 multiplied by 1 plus 2 multiplied by 4 plus 3 multiplied by 6 plus 4 multiplied by 7 plus 5 multiplied by 2 and divided by 20. And then it shall come out to be 1 plus 1 is 1, 2 and 4 is 8, product of 3 and 6 is 18, 4 multiplied by 7 is 28, and 5 multiplied by 2 is 10. So this whole divided by 20 comes out to be 65 by 20. When you go on to solve using calculator, it comes out 3.25. So the average rating given by the 20 critics of the movie is 3.25. Again, you see that how easily we found out of just one number using these special tools of statistics, and we simplify our understanding of this enormous amount of data. So that is the beauty of these different tools of statistics. Second, someone may ask you that what is the median of this data set. Now again, how many data values are there in our problem? Total 20 data values are there in our problem. That is an even number. So our median then shall going to be average of two middle numbers, and these two middle numbers is n by 2 and n by 2 plus 1th. N by 2 is 10, n by 2 plus 1 is 11. So the median is going to be the average of 10th data and 11th data. Now the 10th data is where? Now you see, one important thing that you must do in all median problems is that you must arrange all of the data in ascending order. In the problem, however, our data has already been given in ascending order. 1, then 2, then 3, then 4, and then 5. In the first column, you can see this is in ascending order. Had that not been the case, we would have been first arrange the data in ascending order. Now that already data have been given us in ascending order, we find out which one is the 10th data. See, the first data is 1, then the 5th data shall be 2, then the 6th data shall be 3, and if you can see that your 10th data shall also be 3 and 11th data then again shall also be 3. Similarly, your 12th data then shall be 4, then from 12 to 18th data shall be 4, and 19th and 20th data shall be 5. We want to know only the 10th and 11th data, so the 10th data is 3 and 11th data is also 3, so the average of 3 and 3 is also 3, so the median is then 3. Mode. Now we want to know what is mode. The mode is the data value for which the frequency is maximum, which is coming most often. You see from this frequency table that rating 4 is coming most often. So the mode then is going to be 4. Its frequency is a maximum and hence mode is 4. Now what is range? Range is a spread. Range is the difference between greatest value and lowest value. That is 5 minus 1 equals to 4. Here many students sometimes confuse that the data values are on the right hand side and they do the range as 7 minus 1 equals to 6. However, this is not the case. Remember, the different data values of the data set are always 1, 2, 3, 4 and 5. The frequencies are just telling us that how repeatedly they are coming in our data set. The frequency is not the data set.